Next one is powers. So unlike multiplication, when you raise something to a power, you're raising it, it's like a higher order mathematical operation. Remember that, well, I'll show you an example. Let me tell you the rule first. So we have x raised to the a, and then all of that is raised to the b. So in this case, it becomes x raised to the a times b. And this all came about because exponents were designed for times when we didn't have calculators, and so they are basically designed to turn things that are like multiplication into addition, things that are like powers into multiplication, so you're taking everything down a step. All right, the example I wanted to show you is when you have x raised to the second power, all raised to the fifth power. Remember, that really is saying you have x raised to the second multiplied by itself 5 times. That's really what an exponent is designed to be. So then you can see it's x raised to the 2 plus 2 plus 2 plus 2 plus 2 5 times. Or x raised to the 2 times 5, or x raised to the 10th. All right, second example, m raised to the 7th times n raised to the 4th, and it's all raised to the 4th power. That becomes m raised to the 7th times 4 times n raised to the 4th times 4, or m raised to the 28th power times n raised to the 16th power. And finally, we have c times d raised to the 2nd power, all raised to the 3rd power. So since we have that magic hidden 1, I'll break this one out too. So it's basically telling us we have c times d raised to the 2nd multiplied by itself 3 times, since that's what the power of 3 means. So this becomes c to the 1 3 times. So you can either look at it as c raised to the 1 times 3, or you can look at it as c added together 3 times. I'm going to write it as c raised to the 1 times 3 because that's our power rule. And that's multiplied by d raised to the 2 times 3. So we end up with c raised to the 3rd power and d raised to the 6th power. And then looking at them when we have a coefficient in front of the variable, you raise the coefficient to the given power, and then you simplify the variables with the power rule. So 5x to the 7th raised to the 2nd power, that's like 5x to the 7th times itself, so 5x raised to the 7th. It becomes 5 squared times x to the, actually let me write it in the order that it is. X raised to the 7 times 2, or 25x raised to the 14. So 2 times x to the 2nd times y, all raised to the 5th power, becomes 2 to the 5th times x raised to the 2 times 5 times y raised to the 1 times 5. So we have x to the 10th power, y to the 5th power. 2 to the 5th power will be 2, 4, 8, 16, 32. So that's 32 x raised to the 10th, y to the 5th. All right. And now we have minus 2, p raised to the 4th, q raised to the 6th, all squared or raised to the 2nd power. So we're going to have minus 2 squared times p to the 4 times 2 times q raised to the 6 times 2. It's really important to remember you have your minus sign. If you're putting this in your calculator, you have to put parentheses around it. In your calculator, if you put in minus 2 raised to the 4th, or the 2nd, sorry, this is to the 2nd power. If you put it in your calculator directly as minus 2 raised to the 2nd, your calculator is going to do the 2 raised to the 2nd first because of PEMDAS, and then multiply by minus 1, so you'd get a minus 4. But if you put it in your calculator in parentheses, then your calculator knows the whole thing is raised to the second power, which gives you a positive 4. So this is 4 times p raised to the 8 times q raised to the 12.